Hello, I am Agnes Leroy, Senior GPU Manager here at Zama. So I work on the TFHE-rs library, which is a Rust library that makes it possible to perform computations on encrypted data, and the supported formats are booleans and integers. So we just released version 060 of TFHE-rs with a lot of new features, and today I'm going to show you how to use GPU acceleration in the library. So we're going to look at a very simple example of money transfer between two accounts where all the amounts are encrypted. So we're going to look first at this function, the transfer function. You see it takes as inputs the amount on the accounts we're transferring from and to, and the amount that we want to transfer, all in the form of encrypted integers with 64-bit each. And it's going to return the same type of data for the new amount on the account we transfer from and the new amount on the account we are transferring to. So what this function does, very simply, is that it checks whether the account has enough funds, and it does it homomorphically. So this has enough funds variable is actually an encrypted boolean, and we use it in this if then else function to update the value on each account. So if the account that we're transferring from has enough funds to perform the transfer, we're going to update the values with the sum of the amounts or the difference. And we return the new amounts as output of this function. So let's see how to use it. First, we're going to do some setup on a client, and here I'm not really setting up a client on a server. I will just explain what happens on the client, what happens on the server. So on a client, we first create a configuration. So here I'm using custom parameters because I'm actually going to change those when we switch to GPU computing. Then we create a client key using this configuration, and we create a compressed server key that we're going to send to the server to perform the computations. Then we define some amounts on the accounts and the amount we want to transfer. So we are going to have account with $100, one with 0, and we're going to transfer 50 between the two. And we encrypt those values. So here you see we have this TFHE Win64 type to specify the type of the data. So we encrypt using the client key that we just defined, each amount, and those we would send to a server to perform the actual computation. What happens on the server? So it receives this encrypted amount, it receives the compressed server key, and first it decompresses it, and it executes the transfer. So here, since our compressed server key is a CPU one, the transfer happens on the CPU. And then the server would send back the encrypted data to the client, and the client can decrypt it using its client key. So let's execute this. All right, so we see that we had $100 on the first account, we transfer 50, and at the end we have 50-50, which is what was expected. And it took 612 milliseconds to execute this on the CPU that's on this machine. So you will find in the documentation the reference benchmarks for the CPU, which were run actually on a much bigger CPU than the one that's on this machine. But today I'm going to show you how to run this on an H100 GPU. So that's actually the GPU we use in the reference benchmarks in the documentation. So let's do that. What we want to do here is that instead of using this compressed server key to run the calculation, we're going to define a GPU key. So instead of just decompressing it, we decompress to GPU. And here we use this GPU key simply. And additionally, I'm going to use specific parameters for the GPU for better performance, basically. Here we go. I'm just going to modify my import as well. There we go. And that's it. Let's execute again. And we see that now the execution of the transfer takes 378 milliseconds on this H100 GPU. So that's it for today. Thanks a lot for watching this video. I hope you enjoy working with TFHE-rs 060. Be sure to check our blog post regarding the release where we explain all that's new. And yeah, I hope you enjoy using the library. Bye.